And we'll continue with two speakers now on our stage. We had the one already here yesterday, Dr. Hana Niederbrucker. She's today here with her colleague, Anja Fessler, also product manager in corporate IT at ZF. We'll learn from them about computer vision toolbox on the road to computer vision and AI quality inspection at scale. So you'll connect a little bit on what we discussed yesterday, scaling AI with a concrete example. Very excited to learn about how ZF is using AI in order to do quality inspection. Over to you.
Thank you for the nice introduction. So how to connect computer vision and how to scale AI quality inspection at scale. To give you some inspiration and to share some insights, some information, Hana and myself would like to use the next 15 minutes. Starting with giving you a bit more context. So where are the ZF internal customers? And more important, who are the potential computer vision toolbox customers? Here we need to highlight actually the ZF internal locations around the world, with having 95 locations in Europe, 32 in Asia, 31 in North America, and also some locations in South America and Africa. That means here we are seeing our potential customers which are sitting around the globe. With having in total 188 production locations, 18 main development locations, as well as 50,000 workshop partners. And those connected together are actually helping us for providing a large product portfolio like the following. Then besides offering software solutions, what ZF nowadays as technology group is doing, we are also offering enabling products for the mobility sector. That means in the context of automotive, commercial vehicles, as well as technology components. That means on the left side, you could see the wide range where we are using our enabling products. And on the left side, you could see our large product offerings. Here we are having chassis, axles, and other products, to mention only a few of them. But what is the problem now? I mean, we are having locations around the world, we are having many product locations, and we are having a large product offering. What is now the challenge? Process challenges, material vulnerabilities, as well as faulty deliveries are cause porosities, cracks, or generally quality defects. As we, as company, would like to guarantee high quality standards for our OEMs, that means for our external customers, but also internally, we would like to guarantee a quality standard. And besides that, we would like to trace back our components, we would like to achieve images, and also would like to use the technological potentials which are out there. These are our motivations why we are seeing the need for developing an automated AI-based quality inspection. But how to approach this automated AI-based quality inspection and how to overcome potential roadblockers which are out there. Hana, could you give us some inspiration how to do that?
Yes, of course. Thank you, Anja. So learn the context in which we are now with the products, with the big variety of the customers. What is the current situation? So there is a big need for automated quality inspection due to the big variety of products. And there are already some existing solutions locally in the plants. But what is the problem for the ZF if you look from the company view? There is no standard available. So if there are a lot of prototypes, a lot of individual solutions, so everyone just found their own vendors, their own partners and contact persons to work with. So no no standard available, which means also high maintenance, also cost and also in terms of time, because you always have to contact your contact person, your external vendor. There is also usually the solution as a black box, so you can't take care of it yourself in the production hall. So you always have to call somebody. This also leads to long deployment times because everyone has to start from scratch. So if someone in Europe started such quality inspection solution, they had to find out which camera settings, how I connect the camera, and everything from themselves. And they did not learn that someone else in North America or in Asia already did it. So this really takes, recently I saw a presentation in journal where they stated that they took them 4 years to come to the quality inspection solution. So if you have a problem, you can't wait years, to then detect it, because then the problems has changed or something. So there's also a big problem. And all of the things leads, of course, to no scalability. So if you don't have standard, if it takes long time, if you have to take care of it individually, then it does not scale. And we want to provide a solution to all of the plants. That would be the vision. So let's have a look at the solution itself. So what is actually computer vision toolbox? What does it? What is integrated? What is the content? So here we see the whole toolbox at once, what it means. So on the left side, you see the local part. So it runs in the company. It's on the CVT, in the production hall, local in the factory, on the edge. And then it goes to the cloud, and it consists of 2 platforms. So we also try to, since it's in-house solution, we also try to leverage already the platforms existing in ZF. One is the DMP, which is the digital manufacturing platform, and this platform really takes care of connecting the machines and the production hall to the cloud, which needs to go through a lot of security checks. So it's big work. So we use already this existing platform for communication with the cloud. And then we have the AAP, which is Advanced Analytics Platform, and this platform serves for archiving data and especially aims for analyzing the data and giving access to data scientists and providing them tools to create models, training models. So one more time, if we now know what is DMP and AAP. So there is the local solution when the CVT toolbox provides communicating the camera, setting up the camera, taking the picture, also communicating to the machine, because we always need to get, for example, trigger for the camera when the product is ready on the production line. So we need to communicate with the machine or instruct it afterwards. Then the images are sent to the cloud over the DMP, which they may be labeled, and then stored in the AAP in a corporate data lake when they are archived, also with the metadata, which is needed to then search for the images and to train the model. If we have trained the model, which, for example, detects the defect of the product, so some wrong polished cogwheel, or there is some part missing on the product, then if we trained this product, then we deploy it back. Respectively, we first store it in a registry. So we also integrated an AI model registry where we want to store the existing model and for the purpose of reusability. So because the problems may, or the problems in the ZF, it's not that only one location has one product, but the products are processed in a different locations, and that's why there is a big potential for reusability. So the model may be stored and then deployed in the one concrete deployment in the factory to process the taken images. So this is basically the framework, the software package, or the platform, and you want the toolbox, which is then common for all of the customers. So it can be deployed to all of the factories. But you may ask yourself, there's also some individual problems which, for example, the AI model. The AI model is not for all of the location the same, because there may be different products. So we also have to take into account some configurability of the solution. So there are some specific parts, of course, as the AI model, but also the camera settings, or also data lifecycle management, because for traceability purposes, we have to store the data for a longer time, or there may be some other conditions or for some other pictures. So this also has to be individually configured, and also the updates of the whole software, because this has to be aligned with the production schedule. So we can't say, okay, now all of the software will be updated on Sunday at 12, because it may also collide with the production, and we have to make sure that there are no downtimes in the production due to software updates. So this is also a challenging aspect of the whole solution, because it's rather complex. So if we go back to the roadblockers, as we mentioned at the beginning, how does it look? So if we now have such a solution, then it could be used as a standard, because we designed it so that it could be suitable for all of the plants. And it also leverages the standard platforms. Then also it's no black box, so the maintenance is easier, because we know the solution is in-house built, and also the deployment time using a standard is shortened rapidly. So all of those aspects lead to better scalability. Of course, there are many more aspects. Now we can have a look at some more. They are mostly the technical ones, so we have to take care. What I wanted to say, that it's also a difference if you deploy it once or if you deploy it 100 or 1,000 times. So we have to make sure that also the monitoring of the instances scale, and last but not least, one important aspect, trustworthy AI. We heard about it yesterday a lot. So we have to make sure that also the customers are trained, that they trust the solution, that they know how to use it, and all of the things we have to take care of. So as I said, there are a lot of technological aspects. We heard yesterday there are much more, which are not listed here, about organizational mindset, people. So it's a very, very complex solution. But since we use an AI model, it's also important to take care of deploying the AI model and taking care of the life cycle of the AI model, which come to the MLOps topic, and I will ask Anja to tell us more about this.
With having in mind that when we are talking about the computer vision toolbox, we are talking about an AI product, we need to consider MLOps approaches for the operationalization of the whole AI product to use it successfully and to have at the end a robust solution in place. Based on our experience and based on our focus topics right now, we would highlight within the MLOps context right now those 6 fields which we are seeing as quite relevant. Starting with process, I mean, having good beneficial processes in place is always a good thing to have. But having especially for the model testing a framework in place which makes sure that our model which we are deploying at the end is in a good quality is quite beneficial for us. On the other side, talking already a lot about people and having the right skills in place. Also within our MLOps approach, we would like to make sure that we have along the whole ML machine learning lifecycle the right skill sets and the variety of skill sets in place to make sure not only having the data scientists, but also for sure the software developers and so forth. And having those people with the right skill set, we need also to make sure to have the right ecosystem of tools in place. That means we would like to guarantee that those people have this ecosystem full of tools which guarantee speed, creativity, and also safety. Due to the fact that at the end we would like Hana mentioned already, to make sure that we have also some trustworthy AI values considered, we are also focusing especially on observability. That means making sure that you have monitoring in place for sure and logging in place is quite relevant, because I mean, when the model is deployed, it's not the end of the whole life cycle. So having observability topics in place are we seeing as quite important. To mention the last 2 of our topics here. Like Hana said, we would like to deploy it in various locations around the globe. That means having robust and automated pipelines is the foundation of everything. And as a last point to mention here concerning reusability and information sharing, knowledge sharing, also having a standard for documentation is a quite relevant point we need to consider on which we are working quite closely here. To bring it together, what is the main goal of those topics? At the end, everything comes to having a robust model, and having it deployed in the production is the huge goal of everything. Due to the fact that we only mentioned now somewhat details about MLOps, we are quite happy to discuss also about the other topics with you later on. With that, we would like to say thank you and hope that we have the one or other discussion later on. And thank you for being with us on the road to connected computer vision and AI quality inspection at scale for the last not fully 15 minutes. Thank you.
Thank you both very much. We'd also have a few minutes for question. If anyone wants to ask something, just raise your hand. My colleague Nina will find you, and there already is someone. So Hana and Anja, thank you so much first for the insights, and over to you.
First of all, thanks for all those insights. I have a question regarding those models. Are you able to use those models which you have trained on one plant for another one?
That is actually the main goal at the end. We are right now in the developing phase and the pilot phase. That means this year is especially essential to try it out in which way we especially could use it, but that's the main goal, to reuse it.
So you could pre-train a model in one plant and use it for another product in another one.
This is one challenge we are now standing for, because we have a customer who has many production lines with similar products, and they are really in time pressure. So this is exactly the challenge when we try now in the next 2 months, where the first one has to be ready in 2 weeks, and then the last one, the next one, like 1 month later. So this is quite some challenge for the data scientists. So we have the framework for it, but how it works in the practice, or how you're able to train a model, so it would be great, but let's wait for so we then evaluate how it works, but we have definitely either completely the same product, then it depends on the camera settings, if it's the same, if you can really, how sensible is the model, or in this sense, when you have similar products, that is a very good test for us how to reuse it. But we built a framework for it, that it's necessary, that it's possible, not necessary, but possible.
Thanks.
All right. A second question. Okay, Nina has to. Okay,
Sorry.
even more questions. Sure.
Can I speak
go
up?
ahead. Yes.
Yeah, I'm Julia from BSH Home Appliances. So I think we have several use cases compared to yours. And what I would be interested in, you are competing with external suppliers, and you are heavily depending on business competence and resource to train the model. So what's your approach to that?
So you are now referring to the AI models, right?
Exactly.
To the
overall
intelligence
application on how to compete with externals.
So first, so we focus on the also in the house. Yes, it's a competition, so it's also a trade-off what we have to buy and what we have to make ourselves. We now put so we have AI center of competence, so we have internal data scientists, which also have the domain expertise. And we think that it's also important, or it's one of the aspects that we start from a different starting point if we have the domain knowledge in-house, and then you can build up. And if it's, it's not necessary, or it's not planned that one data science team will do all of the use cases, but one data science team can do more or several use cases, and then you know already the product. So this is, I don't know if it answered a question, but that was those thoughts we have, like, let's try it in-house because we have the competence, we have it inside, and we have the domain knowledge in-house. So let's try it. But we also don't exclude to bring in external solutions. So the toolbox is built up in a modular way, that the AI model is like a plugin which you can just connect. So you somehow deploy the framework and then you choose the AI model, and it could be also developed externally and plug it in. But then we are again at the disadvantages that if you want to adjust something, if some camera settings changes or if background changes or there is a bit another product, then you have to call some, and you don't have the possibility to reuse it.
Also one additional note here, we are seeing the huge advantage of collecting, all those data of all our production halls and having at the end a data lake full of our internal and product data, which we are seeing as, quite beneficial. So having like a connected solution internally developed makes sense. Like Hana said, it's always like a consideration of make versus buy for sure, and how to involve also external solutions. But the huge vision is to have like all those benefits gained through the internal solution.
And to learn also on the way. So if we buy an external solution, we have it as a black box, but then you can learn. Yeah.
All right, I think we have one and maybe very quick another question.
So also thank you very much for the nice presentation. So my name is Thomas Freund from EDI. So we also already work together with ZF, so this is why I'm really interested. So you mentioned the vision, so all the data from the shop floor should get in one database. You have an estimation how much percentage of relevant data, so also quality protocols which maybe are stored in some Excel sheets or somewhere, you already get in this database for this kind of AI analytics things.
So this data archive, which Anja mentioned, is mostly really collecting the images from the camera plus the timestamp and maybe the information about the product. What is also inside is the connection to the digital manufacturing platform, and this is for that they collect all of the. So the vision is to collect the production relevant data to the digital manufacturing platform, where we could add the quality data, the images, and put it together. So we are not aiming on collecting all of the relevant data, but we are trying to find synergies with the digital manufacturing platform, which take care of connecting different systems and putting together the production relevant data, and we add to the quality data of the products with the images where they can train them on.